Ruby on Rails 8 is meant to be a transformative milestone for Rails that truly makes it a one-person framework. A popular tagline for Rails 8 is from Hello World to IPO, and after using Rails 8 for a while now, I can definitely say this is the best version of Rails I have ever used, and I've been using Rails throughout my whole entire career as a software developer. But what does it mean to go from Hello World to IPO? Well, the most important piece of building an application is actually shipping code, and Rails 8 makes it easier than ever to ship code to whatever server you want, and this is all accomplished through two basic technologies, Kamal and Docker. And in this video, we're going to unpack the Dockerfile that Rails 8 ships with that you can push to production anytime you want. So let's get into it. When deploying an application in Rails 8, we utilize two main concepts: a container, more specifically a Docker container, and a deployment tool called Kamal. In this series, we've been building an application, right here actually. It is a beautiful task management application. We can show tasks, we can edit them, we can move them from in progress to completed. We have all kinds of cool tools going on here, and we've been building this application throughout this series here, Rails 8 Unpacked. And by the way, if you want to check it out, there's a GitHub link down below. You can follow along with this series with that GitHub link. And in this series, we're not just building this app, we are going to deploy this app to production, a live production server. But first we need to understand how Rails 8 deploys code. And in this episode, we're going to tackle the Dockerfile and why we need it for deploying. But first, what the hell is Docker again? Chances are you've at least heard of Docker many times throughout your career. I know I have, but I never took the time personally to learn Docker very well and understand what makes it so powerful. So real quick, let's just go over Docker, containers, and why we use them for deployment. First of all, what is a container? Well, by definition, a container is a restricted runtime environment for a set of processes. In containerization, we isolate a number of processes within an operating system so they can't touch or interact with anything outside of its scope. Now, this is achieved by using certain tactics. So let's just draw a little diagram here. Let's say this is the host operating system, okay? We can call this the host OS. Now, in containerization, what we want to do is actually run a set of processes inside the host operating system. This is the container. Now, within this container, you can run a certain set of processes that will actually be completely isolated from the rest of the host operating system, even though it's using the host OS's resources. And we isolate these processes through a number of different tactics. One of which is a chroot command, which allows us to create a new root that these processes can live within, so they can only interact inside of this root and not touch anything else in the system. There's also some other things like a kernel flag called rlimit, which limits the amount of actual hardware that this container can actually use. And there are more tactics than just this, but that's the essential way that we use containerization. We have a set of processes that are isolated within a host operating system. Now, managing C groups for processes, resource limitation, and all of that stuff can be done manually, but it's tricky to say the least. So there are programs that help with the management of these containers, and a great example of that is Docker. So if we go back to our diagram here, the program that sits above a container is a program that controls those containers, and a very common program that controls containers, the life cycle of them, spinning them up, shutting them down, building images out of Docker files. We'll get into that in a second. This is what Docker does. It manages the life cycle of containers and everything around them so that you don't have to worry about the nitty-gritty details of separating these processes into small groups that don't touch anything else in the operating system. Docker does this for you. So how do we build containers? Well, the thing that we start with is a Dockerfile. Now, the Dockerfile is a thing that contains all of the instructions that Docker will use to build something called an image. Then we use this Dockerfile to build an image. And a Docker image is a template that contains all of the files, the libraries, and dependencies of a program needed to run an application in a container. And then you use the image to run a container. And a container is a sandbox environment that runs a program in your machine. This environment contains all the necessary dependencies to run whatever program needs to be run because it was all packaged up within the image that was built from the Docker file. So to sum it up, you have a Docker file, which has a list of the programs that should be installed. You have the image that is a template with all the programs sort of packaged up within it. And then you have the container, which is a sandbox environment that runs the image inside of the host operating system. So now we have a quick refresher on how Docker works and why you would want to use it. Essentially, it is a tool that allows you to build an application with all of its dependencies and run it in a host operating system without touching anything inside that host's operating system. And you could package up your applications and run them pretty much anywhere independently. But what does a Dockerfile, aka the list of ingredients needed for an image, look like in Rails 8? Well, thankfully in Rails 8, we have a highly efficient and tuned Dockerfile for turning your application into a production-ready container out of the box. Now, what the hell does that mean? Well, let's check it out. It's actually in your code base right now on a Rails 8 app. So let's open up our application, and again, check out the GitHub link down below in the description if you want to follow along here, but any default Rails 8 application will come with this Dockerfile, and we open up our Dockerfile at the base directory of our application. And here we are. Beautiful, isn't it? So this is the base Dockerfile for Rails 8, and it has everything you would need to deploy your application to production wherever you want to deploy. And this being a Dockerfile, remember from our previous conversation, this is the list of things that we use to build an image for Docker, that then we take that image and run a container based on that image in a host operating system wherever we deploy. So this is the list of ingredients that we use to create an image for our Rails 8 application to then run later. So let's go line by line and kind of break down what's happening in this Dockerfile so we understand what it means to build this Rails 8 app into an image and container. So this very first line here is an arg line. This is basically setting a variable that we're going to use later in this file. And this line specifies the initial image we're going to use to build the image for Rails 8. Now, every Dockerfile needs a place to start from, and typically it is a base image, which is a very simple and stripped down version of something like Ubuntu or Debian or whatever else, something that you can use to install packages onto and then run your application with. And with Rails 8, by default, we're installing from Docker.io, which is the Docker hub, an image that is named Ruby with the tag of Ruby version -slim, and that is going to be our base that we are working from. Now, where does this image live? Well, you could go to Docker Hub, which after you sign into Docker, I click on Docker Hub here, and I could search for Ruby 3.3.5. And let's see what I come up with. And here we are. This is the Ruby image, and we can see that we have a ton of different tags on this Ruby image. Now, what this is a pre-built image that has Ruby pre-installed at certain versions, and it has everything you would need to sort of get started with a Ruby on Rails application when it comes to building it. And we can see in our file, we specify Ruby 3.3.5 slim. That is the tag for the Ruby image we are going to be starting from as our base. Got it? Good. Next, we have a line that specifies the working directory. This creates a new directory in our image that we can then put files into. And in this run command, what we are doing is we're installing all the packages that we need to build our Rails project. This is pretty straightforward stuff. You can see here that we are using Postgres in our application. So we have PostgreSQL client as part of the packages that we're going to be installing. And then down here on line 20, we are then cleaning up all of the packages that were installed and all the things that we actually don't need on our system after we've installed these packages. And on line 23, we set some environment variables that we use when we're building our Rails application. And on line 29 here, we see a kind of special line here that's a little bit different from what you would see from very basic Docker files. This says from base as build. Well, what this line does is that it's part of a multi-stage build process in Docker that we use in Rails 8 to build our image. There are a lot of benefits to using a build stage, and the main one is to reduce the final size of our image. Basically, what we're doing here is we're creating a new stage in this Docker file based on the base image that we just installed, and we're going to apply some packages to it. We're going to build some stuff, build the code, compile some assets, and then we're going to copy all of that stuff back into our base image, and this extra build stage is not included in the image itself, meaning that we can build up all of these things, we can compile assets, do all that stuff, and then throw away any of the things that aren't required for actually running our application. This reduces the overall size of our Docker image, which is a good thing. And so now if we look further down this file, we can see that it's doing exactly what I was describing in the stage definition. We're going to install some packages, copy some things over to this stage, and then compile stuff for our application. Then when things are all compiled and ready to run, we copy our compiled stuff back to the main stage, and all the stuff we use to make the compilation gets thrown away. This helps us keep our final image small. We can also see on line 37 here, we copy our gem file from our local device to this image. We then run run bundle install, which installs all of the gems that are needed to run our Rails application. And then we copy the rest of our Rails application from our local device, which is the current working directory, to where we currently are in this image, which is /Rails. Remember, we defined the work dir up above. Then we precompile some boot snap code, which gives us faster boot times. And we precompile all of our assets using bin Rails assets precompile. And this line 49 right here, uses propshaft to stamp all of our assets with their current hash values based on the contents of those files. We talk about propshaft in a different episode. Go ahead and check that out if you're interested. It's really interesting. And then on line 55, you see that after we precompile everything and everything is compiled in our Rails application, we go back to our base stage of our image. We then copy all of the built artifacts, the gems, the application code from our build stage to our base stage. This is the part of the Dockerfile that shows how our image is going to be small when we finish building it, because we created a whole new stage, built everything there, and now we copied everything from that build stage into our base image stage. Then on line 62 here, you can see that we changed the actual user on some of these files to be a non-root user so that we have some extra security in our image. And on line 68 here, you see we have an entry point instruction. The entry point instruction is used to configure the executables that will always run after the container is initiated. And if we want to actually check out this entry point, we can check it out in bin docker entry point. And you can see here what it does is before every time we initiate our application, it runs bin Rails DB prepare so that we always have the latest schema applied to our database. Pretty nice. Then at the very bottom here, we see we expose port 80 to be the port that we use to listen to in this image. And we have the very bottom line here, which is CMD. CMD is the default command that gets run whenever this image is executed in a container. And you can overwrite this on the command line if you want, but you probably wouldn't do that. And what this does is starts Thruster, which is a built-in proxy for Rails, and then it starts our Rails server, and we should be off to the races. Okay, so we have this Dockerfile. You can use Docker to build an image based on a Dockerfile. So let's build this image. So we can call Docker build, and we can tag this with test something, and we specify dot as the directory to build from because this base directory here has our Docker file. And we run Docker build, and we can see that Docker is doing all of the things in that Docker file. It's installing the base Ruby version. We're then calling run bundle install. We're doing all of the pre-compilation stuff. We're copying all the things over from our build stage into our base stage. We set some environment variables. We do all that stuff, and all of a sudden we're all done. So this is how we build the image using Docker from our Rails 8 application, but it's meant for production, not for development. How are we supposed to use this? Well, in order to find out, check out our episode on Kamal where we actually deploy this thing to a live server. And hey, thanks nerds.